Kia ora, Year 9. Here come questions 11 and 12 from practice test 2. So there are a couple of things in here. The first one is revising some of the kind of number theory stuff from earlier this year, which was all about factors, prime factors, and all of that. And then the second part of this is a wee question on ratios, which we haven't done in class yet, but I'm going to do it in here anyway. Right, so let's have a look at what we've got. I want you to pause, as usual, and have a crack at the questions on your own. And remember, there are different ways to do some of these. So my way is one way. If you're watching this from another class, your teacher might have taught you a different way. It's always good to know more than one way. So what are the next two prime numbers after 31? Remember, prime numbers are numbers that have two factors exactly, 1 and the number itself. So we know that the only even prime number is 2. So let's think about the numbers coming after 31. And we're just going to write a few of them out and then have a think. We want to find the next two of them. And we can always knock some out, right? So this was the idea of the sieve of Eratosthenes that we looked at in class ages ago. So 32 is not a prime, 34 is not a prime, 36 is not a prime, 38 is not, and 40 is not, because they're all even. Now let's think about 33. Well, that's not a prime because it's got factors of 3 times 11, so that's gone. 35 is not a prime because 7 fives. What about lonely 37? Well, 37 is our next prime. So let's think about what it's got. Has it got a factor of 1? No, yes. So it's got 1 and 37. 3 is not a factor. Remember, we can tell that quickly. Well, we know it's not a factor because we know 3 is a factor of this one here. But also we can add the digits up and we get 10, and 10's not a multiple of 3. So that was one of those quite cool divisibility things that we played around with earlier this year. So 37 is not a multiple of 3, it's not a multiple of 5, it's not a multiple of 7, it's not a multiple of 9 because that was here, it's not a multiple of 11, it's not a multiple of 13. So remember, we looked at in class, how far do I have to go before I'm happy to say that it's a prime? And I've got to go, let's think, 13, 15, 17. None of these are factors of it, and neither's 19. And then I'd start going back down. So I don't have to check anymore. So 37 is the next prime. Now you're probably going, why did she take so long to do that? Well, I didn't need to do it for this question, but I want you to just have a general revision of what prime numbers are about. So that's the first one. Now what's next? Well, 39 is not a prime because 3 is a factor, right? 3 13s. So let's keep going. We'll put down a few more and see when I can stop. Right, so the next prime is 41. Right, so you can look at trying to do your factors on that. The only two factors of that are 1 and 41. So the answer here is 37 and 41. Okay, use a factor tree to express the prime factors of 756 using powers. I can hear some of you going, why do we have to learn this stuff, miss? Well, this is really, really helpful for another mathematical skill, which is, well, the main one is factorizing, right? And so we practice this skill in the abstract because it's going to help me as an input into other skills, and sometimes those skills might or might not have real life uses. So here's 756. We can start this off anywhere we want. You could go 2 watts of 756, but I said, okay, let's start with 3 times something is 756, because I can see 250 will get me that times something here. So it's going to be 252. Right, is this a prime? Yes, it is. Circle tick. Next one. 2 times 126. Circle tick for that one. 126. Let's see what we've got here. Well, we could do whatever we want, but I'm going to do 3 again. So 3 is a circle tick because it's a prime. 3 times 42. Right, what are the factors of 42? Well, the easiest one to see is 7 sixes. 7's a prime, circle tick. But 6 is not yet a prime, but 6 is 2 times 3. Circle tick, circle tick. Now, we're going to write that as the product of prime factors. So I'm going to do that using exponents. So we get 756 is equal to 2. Right, how many 2's did I have? I've got 2 here, and I've got 2 here. So that's 2 squared. 2 to the power of 2 times, what's left? 3 times 3 times 3. So that's 3 cubed. And the last one left is times 7. Right, now I'm going to check this by multiplying out. So I've got 4 times 7 times 27. So 4 here. So 28 times 27. Let's look at whether we get what we want to. So I'm doing algorithm for multiplication here. So we get 7 8s are 56. So we get 196 here. And then put down the 0, 6. Carry the 1, 2 2s, 5. Let's see. Does it work? No. What have I done? I can't add. 6, 15. Oh no, it does. It does work. 756. There we go. Right, one more method that I want to go over for multiplication is the grid method, which I really like. So that 28 can be split up like this. 20 and 8. And then here I've got 20 and 7. So when I'm multiplying here, I get 400 here. I get 160 here. 140 here. And 56 here. And that's really easy to add up. So adding here I get 540, and here I'm going to get 216. That gives me a total there of 756. So this is the method that lots of you will probably know from your mums and dads. This grid method is another way to do it that I think is cool. Anyway, that was another detour, but a useful one, I hope. Right, next one. What's the highest common factor of 72 and 108? So this time I'm not looking for the prime factors, I'm looking for the factors. So the factors will not all be prime numbers. How can I do this? Well, I can write out the factors of 72. I've got 1, and there are a lot of them. 1 and 72. 2 and 36. 3 and 24. I'm going to run out of space. 4 is not a factor. 4 is a factor of 72. 4 18s are 72. And I have run out of space. Oh dear. Right, so 4, 5's not a factor. 6, 12s, and lastly 8, 9. So 72 has a lot of factors. Right, let's do 108. So you don't have to list all of them out, right, to find the highest common factor. But I'm going to. I'll do them for 108 anyway. Because sometimes you might need to give all of the factors. So we've got 2 and we've got 54. Right, 3. Does 3 go into 108? Yes, it does. I know that because the digits add up to 9. So 3 watts, let's think. 3 30s, 3 and 36. So we actually don't have to go any further, right? Because we can see we're looking for the highest common factor. And 54 is not in there. Not in both. But 36 is in both. So the highest common factor here is going to be 36. Okay, what's the lowest common multiple of 6 and 15? So the easiest way to do this is to start skip counting and just listing them out. LCM of 6 and 15. And again, some of you will just know this very intuitively by now, but let's list out in case we don't. So we get 6, 12, 18, 24, 30, ... And I can stop when I think I've hit a multiple of the other one. So that's why I've stopped there. So 15 and 30, you can see that I've hit a multiple in common. So the LCM there will be 30. If you're finding this tricky, remember that Education Perfect has got some really good practice on it. And so has the Alpha textbook. Okay, next one is about sequences. What's the next number in the following sequence? So we're usually interested in either and how we get from one term to the next. So 1, 3, 7, 13. Let's have a look. Well, here I've added 2. What about from 3 to 7? I've added 4. So we start to conjecture that the next one might be adding 6. And it is. So look at this pattern. Plus 2, plus 4, plus 6. So the next one's going to be what we get when we add 8. And it's going to be 21. Right, the last question is this one I mentioned about ratios. Divide 39 kilograms into the following ratio. So ratios are really useful when we want to split something up into unequal parts. They're pretty closely related to fractions. The hardest thing about them is this idea of the colon, the dots separating each bit. And what this is telling me is the total number of parts. So this is saying that maybe Anna gets 2 parts, Bob gets 4 parts, and Catherine gets 7 parts. How many parts are there altogether? Well, the first thing I do when I see a ratio problem is that I work out the total number of parts. So total num of parts, 2 plus 4 plus 7 equals 13. So each part is equal, so that means that I've got one part. It's 39 divided by 13, which is 3 kilograms. So now we have to put the parts back together to Anna, Bob and Catherine and see what each of them gets. So one part is 3, so what are we doing? 2 to 4 to 7. So she gets 2 parts, 6 kilograms. Bob gets 4 parts, so he gets 12 kilograms. And Catherine gets the rest, which was, what was it, 7 parts. So she gets 7 times 3, which is 21 kilograms. So that's all for now. I'll do some more later on tonight. Thanks for watching.